everyone and welcome back to Algebra 1. Today we are going to begin with a concept review. We're going to start off by reviewing the first three concepts today. Let's get started with concept number 1, which was unions and intersections. Now, please make sure you take a note please make sure you take a note of everything that is on the board. That is very important. This is going to be part of your assignment, but first let's go over an example so you know how to do your assignment, okay? Now, unions and intersections. Here we have 4 sets of numbers or descriptions of what a set should look like, okay? These 4 sets are labeled A, B, C, and D, okay? A, B, C, and D are just the labels for each set, okay? Now, our first set, which is set A, we have 1, 3, 5, 7, and 9. For set B, we have x is a positive odd integer less than 10. That's a description of what the set should look like, okay? For set C, we have 1, 2, 4, and 7. And for set D, we have another description, which is x is a negative integer between -5 and -1. Again, another very specific description of what we're looking for. Okay? Let's move on. Now let's figure out which sets are either union, intersection, or disjoint set with set A. Okay? And this is how we're going to be doing that. Now, set A, we have 1, 3, 5, 7, and 9. Set B, we're asking for a description of a positive odd integer less than 10. Now remember, unions are the sets of numbers that are the same. Like, if they have for example, this description fits perfectly with this set of numbers. That will make it a union. Let's just double check that. It's a positive odd integer. Okay, so positive, all the numbers in set A are positive. They are odd numbers, 1, 3, 5, 7, 9, and they are less than 10. Therefore, it is a union. And that's going to be written like this. A is a union to B. Okay? Now let's compare set A and set C. We have 1, 3, 5, 7, 9. And we have 1, 2, 4, 7. Now for it to be a union, it has to have both sets have to be the same. For it to be a intersection, it has to have 2 or more numbers, in this case, in common. Okay? So do we have 2 or more numbers in common? Let's look at it. We have 1, 3, 5, and 7, and 9. And here we have 1, 2, 4, and 7. The numbers we have in common are 1 and 7. That's 2. That makes it an intersection. That means we're going to write that out. A is an intersection to C. Now let's do our comparison with set D. Set D is a description. This description is of a negative integer between -5 and -1. Now that automatically tells us that this is a disjoint set because they have absolutely nothing in common. Set D is asking you for negative. In set A, we only have positive numbers. So therefore, we already know that that is a disjoint set. Does that make sense? Now, that was pretty easy, right? So for your assignment, what I want you to do is using these same sets, A, B, C, and D, I want you to do what I just did, which was compare set A to all 3 of the different sets. I want you to do that, but with set C. 1, 2, 4, and 7. Now, you already have a freebie because we know that set C and set A are intersections. So, all you have to tell me is whether if set B or set D are intersections, unions, or disjoint sets. Have any questions? Please ask. Let's go on into the next concept. And moving on to the next concept that we are going to be reviewing today is concept number 2, which is using graphs to relate two different quantities. Now, we're going to be relating time and distance. We're going to start off with a table. And let's say, in this case scenario, I am riding a bicycle. If I ride my bicycle for 1 hour, I go the distance of 1.5 miles. Okay? That means that after 2 hours, I traveled 3 miles. Now, what if I traveled 4 hours? How many miles would I have traveled then? I use this equation. I am multiplying the amount of time, which in this case is 4, times how much I would travel in 1 hour. 4 times 1.5 is equal to 6. So I would travel a distance of 6 miles. I do the same thing to figure out my third number. I have been riding my bicycle for 6 hours. Each hour I travel 1.5 miles. That means 6 times 1.5. That is equal to 9. Okay? Now I have my table filled in. What I'm going to be doing now is making my points on my graph. Time is x, which is horizontal on the graph. And distance is going to be y, which is going to be vertical on the graph. Okay? So let's start by marking our first point, which would be x, 2. So we go over 2, 1, 2, and we go up 3, 1, 2, 3. And we make a point right there. Now our next point in x is 4. So 1, 2, 3, 4. And for y we have 6. So 1, 2, 3 more, that's 6. There we have our point. Then we go with 6 horizontal. And then we go with 9 vertical. So 6, 7, 8, 9. And there you have it. That is how we compared how we related our two quantities and graphed them. Okay? Now, let me give you your assignment for this concept. For your assignment for this concept review, I want you to fill in this table and graph what you have on the table. Now, in this case scenario, you're traveling for 3, 6, and 9 miles, and for 3, 6, and 9 hours, and for every 1 hour, you travel 2 miles. So, you're going to be using a very similar formula as to what I used. Now, you're going to take 3, and you're going to multiply it by the amount of miles that you would travel in 1 hour. That will give you your first answer. And you do the same exact thing for the second one and the third one. Okay? Let's go into the last concept that we're going to be reviewing today. Alrighty then, for our third and final concept that we will be reviewing today, it is our patterns and linear functions. Now, identifying the patterns, this is where we learned about our independent variable and our dependent variable, okay? So in this case, like we reviewed in the concept, we have our triangles, which is a pattern, which is increasing 1 each time. And then we have, so we have the triangles. That is, the amount of triangles is going to be our independent variable because it doesn't matter how many triangles there are. It doesn't depend on any certain, it doesn't affect the outcome. However, the perimeter is going to be our dependent variable because our perimeter is going to depend on how many triangles we have. So for example, for one triangle, we have 3 sides, which gives us a perimeter of 3. For 2 triangles, we have a perimeter of 1, 2, 3, 4. For 3 triangles, we have a perimeter of 5, as you can see here. For 4 triangles, we have a perimeter of 6. For 5 triangles, we have a perimeter of 7. Now, that was simple, right? You see how I drew my triangles. You see how I counted the perimeter on each set. So now, for your assignment, I want you to identify the perimeter for the following numbers, which is 6, 7, 8, and 9 triangles. Remember, our independent variable are our triangles, and our dependent variable is our perimeter. If you have any questions on any of the assignments that I have for today, they are 3 different problems, one for each of the different concepts that we reviewed today. If you have any questions, something didn't seem clear, please ask for help. I'm here to help you guys. Now remember, this is just a review, that's why I'm going through them briefly. Again, if you need extra explanation, just ask for it. I'm here to help. I hope to be hearing back from everyone very, very soon, and I hope you all have a very wonderful rest of your day. Goodbye.